projects. In this video, we are going to explain about the project titled Drowsiness Detection System. Introduction. The drowsiness detection system addresses the critical issue of drowsy driving by employing advanced technology to identify signs of fatigue or drowsiness in individuals, particularly those operating vehicles. The primary aim is to prevent accidents resulting from impaired alertness, which can have severe consequences on road safety. Utilizing a combination of sensors and machine learning algorithms, the project continuously monitors key indicators associated with drowsiness, such as eye movement patterns and head position. By analyzing this data in real time, the system can accurately detect when individuals are at risk of falling asleep, especially during activities like driving that require sustained attention. Machine learning plays a crucial role in the project by enabling the analysis of diverse physiological and behavioral signals indicative of drowsiness. By leveraging machine learning techniques, the system can effectively process and interpret complex data streams from various sensors, allowing for accurate detection of early signs of drowsiness with high reliability. The project's primary beneficiaries are individuals who operate vehicles, including professional drivers, commuters, and long distance travelers. By alerting these individuals to signs of drowsiness, the system aims to prevent accidents and potentially save lives. By providing timely warnings, the project enhances road safety by mitigating the risk associated with drowsy driving, thereby benefiting both individual drivers and society as a whole. Objective. The drowsiness detection system's primary objective is to enhance road safety by utilizing sensors and machine learning to detect signs of drowsiness, particularly in drivers, aiming to prevent accidents caused by impaired alertness. By issuing timely alerts, the project strives to improve safety on the roads. Various machine learning algorithms such as support vector machine, Navy-based decision tree, and KNN are employed in the project to classify different states of drowsiness using sensor data. These algorithms analyze the data to categorize instances of drowsiness accurately, contributing to the effectiveness of the detection system. The project categorizes drowsiness into specific classes for classification purposes. These classes include open eyes to indicate alertness, closed eyes to signify potential drowsiness, yawn to denote yawning as a sign of drowsiness, and no yawn to represent an alert state. This categorization helps in precisely identifying and addressing different levels of drowsiness, thereby improving the overall effectiveness of the detection system in preventing accidents caused by impaired alertness. Software and hardware requirements. Hardware requirements of the project are operating system of Windows, processor of Wi-Fi and above, RAM of 8 GB and above, hard disk of 25 GB and above. Software requirements of the project are application is Anaconda, primary language is Python, front-end framework is Flask, back-end framework is Jupyter Notebook, database is SQLite 3, front-end technologies used in the project are HTML, CSS, JavaScript, and Bootstrap 4.
Working modules or flow of work. To implement this project, we have designed the following modules. The first module is importing required packages. This module involves importing necessary libraries and packages in the chosen programming language. These packages include Pandas for data manipulation, Matplotlib for visualization, scikit-learn for machine learning, and Flask for web applications. Exploring the dataset. In this module, the dataset containing relevant information for drowsiness detection is examined. It includes tasks such as loading the dataset, understanding its structure, checking for missing values, and exploring basic statistics. Visualization. Visualization is crucial for gaining insights into the dataset and understanding patterns. This module involves creating various plots and graphs, example histograms, scatter plots, to visualize the distribution of data, relationships between variables, and potential trends or patterns. Data pre-processing. Before training a machine learning model, the dataset often needs pre processing. This involves tasks such as handling missing values, encoding categorical variables, scaling features, and potentially performing feature engineering to create new meaningful features. Train and test split. In machine learning, it's essential to split the dataset into training and testing sets. The training set is used to train the model, while the testing set is used to evaluate its performance. This module involves splitting the dataset into these subsets. Training and building the model. This module involves selecting an appropriate machine learning algorithm and training the model on the training data. The model learns patterns and relationships from the training data to make predictions. Performance comparison. After training multiple models or variations of a single model, it's crucial to compare the performance to select the best one. Performance metrics such as accuracy, precision, recall, and FN score are used for this purpose. Front end development. This module involves developing the user interface UI of front end of the drowsiness detection system. It is a web application, mobile app, or desktop application depending on the project requirements. The front end allows users to interact with the system. Input test data. Once the front end is developed, users can input test data into the system. This can be real time data or simulated data for testing purposes. Get the results. Finally, the system provides results based on the input data. For the drowsiness detection system, this involves indicating whether the individual is alert, drowsy, or in a state of potential danger, along with any necessary alerts or warnings. Each of these modules play a crucial role in the development and functioning of the drowsiness detection system, contributing to its effectiveness in identifying and mitigating the risk associated with drowsy driving.
Algorithms used. To implement this project, we have designed the following algorithms. The first algorithm is modified SVM. Support vector machine is a supervised learning algorithm used for classification tasks. It works by finding the hyperplane that best separates different classes in the feature space. In the context of drowsiness detection, SVM is used to classify different states of alertness based on features extracted from sensor data. It aims to find the optimal decision boundary that maximizes the margin between classes, thereby improving generalization to unseen data. Coming to the next algorithm, which is Navy Bayes. Navy Bayes is a probabilistic classifier based on Bayes' theorem with an assumption of independence between features. Despite its simplistic assumptions, Navy Bayes often performs well in practice and is computationally efficient. In drowsiness detection, Navy Bayes is employed to calculate the probability of an individual being in a certain state of alertness given the observed features. It's particularly useful when dealing with large data sets and high dimensional feature spaces. Coming to the next algorithm, which is decision tree. Decision tree is a versatile supervised learning algorithm used for both classification and regression tasks. It works by recursively partitioning the feature space into subsets based on the values of features. Each partition is based on a decision rule that maximizes the information gain or minimizes impurity. In the context of drowsiness detection, decision tree is used to create a hierarchical structure for classifying different states of alertness based on sensor data. It's interpretable and can capture complex decision boundaries. KNN, K nearest neighbor. KNN is a simple and intuitive classification algorithm that operates based on the similarity of feature vectors. Given a new data point, KNN looks at the K nearest neighbor in the feature space and assigns the majority class label among them to the new data point. In drowsiness detection, KNN is used to classify an individual state of alertness based on the similarity of their observed features to those of previously labeled instances. It's non-parametric and doesn't assume any underlying distribution of data. Execution. To execute this project, first we need to open the code folder which contains the project source code files. This is the code folder. This is the static folder This folder consists of files related to CSS, JavaScript, and Bootstrap. This is the templates folder. This folder contains all the HTML pages used in the project. It includes files like index.html, about.html, and more, which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. This is notebook.ipynb file. This is a Jupyter notebook file which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for data science. This is signup.db file. This file is the database file used to store user information. First, we need to copy the path of the code folder from the address bar of the file explorer. So here I'm copying the path. Now open the Anaconda prompt. Use the cd command followed by a space and paste the copied path and hit enter. This command is used to change the current directory to the code folder's path. Compile the app.py file using the command python space app.py. So here I'm typing python space app.py and hit enter. This command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address, localhost, which is this, and port, which is this. Now copy this local link provided by the Flask framework. I'm copying the link. And paste this copied link into any web browser. I usually prefer Google Chrome and hit enter. So it has redirected us to the sign up page. If we are a new user, we need to register first, but I have already registered myself. So click on sign in button here. So here we need to enter the username and the password which we have registered and then click on login. We have logged in successfully. This is the homepage of the project displayed in the browser.
Click on Let's Start button to begin the drowsiness detection process. After initiating the drowsiness detection, click on Start button to open the webcam. Now click on Run using webcam and then click on Start behavior monitoring using webcam to start assessing the driver's behavior for signs of drowsiness. As the system monitors the driver's behavior, it triggers a beep sound upon detecting signs of drowsiness like yawning and sleeping. If I open my mouth, it means I'm yawning and we can hear a beep sound. So that was a beep sound to alert the driver. And if I'm sleeping, we can hear the beep sound to alert the driver. Now close the camera. The purpose of the beep sound is to alert the driver and prompt them to regain alertness, potentially preventing accidents. Conclusion. The conclusion underscores the successful integration of sensor technology and machine learning algorithms to address the critical issue of drowsy driving. By harnessing these advanced technologies, the project demonstrates a viable solution for detecting and mitigating the risk associated with impaired alertness. The project's implementation leads to improved road safety by providing timely alerts to individuals, particularly drivers, when signs of drowsiness are detected. This proactive approach aids in preventing accidents caused by drowsy driving, ultimately saving lives and reducing injuries on the roads. Through the use of multiple machine learning algorithms and comprehensive categorization of drowsiness states, the project achieves precise identification of different levels of drowsiness. This accurate classification enables the system to issue appropriate alerts, ensuring individuals take necessary actions to mitigate the risk of accidents. By mitigating the risk associated with drowsy driving, the project contributes to the creation of safer road environments. The proactive detection and prevention of drowsiness related accidents not only protect individual drivers but also benefit passengers, pedestrians, and other road users, fostering a culture of safety and responsibility on the roads.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.